Hello world, good morning, good afternoon, good evening. Welcome back to Hero to Superhero series about programming or coding an artificial neural network. Alright guys, we have done multiple lessons. You guys are experts and I hope you are enjoying line by line sections of building your artificial neural network from scratch. So let's see where we are. We have reached pretty advanced level now. We are almost ending the chapter, probably next 1-2 videos. So we are basically, getting into the training aspects and updating the weights. So training aspects in the sense training the neural network, right? So the neural network is trained using stochastic gradient descent, right? So this involves multiple iterations of exposing a training dataset to the network, and for each row of data forward propagating the inputs and then back propagating the errors and updating the network weights, right? So this particular part is basically broken down into two important sections: one, the updating the weights, and two, training the neural network, right? So basically in this code we are looking at updating the weights. So once the errors are calculated, if you look at the code properly, you will understand. I'm hoping you guys are from Python background, you need to understand advanced level of Pythons, not the basics, right? So if you look at this, once the errors are calculated for each neuron in the network via the backpropagation method, they can be used to update the weights. Now what is the calculation, what is the formula for that? Weight is equal to weight minus learning underscore rate multiplied by error multiplied by input. That's the simple thumb rule formula. It's pretty clear, right? Now let me explain this. So where the weight is a given weight, a particular weight, it can be 1.0 or 1.000.1, whatever. The learning underscore rate is basically a parameter, inbuilt user defined parameter that you must specify, and the error is the error calculated by back propagation procedure for the neuron, and the input is the input value that causes the error, that actually caused or triggered the error. Basically it's a root cause for the error, right? The same procedure can be used for updating the bias weight as well, except that there is no input term, or input is the fixed value of 1.0. That's how this particular neural network works. Learning rate controls how much to change the weight to correct the error. For example, a value of 0.1 will update the weight to 10%. That's the calculation. 0.1 is equivalent to 10% of the amount that is possibly or could be updated, right? As small learning rates are preferred that causes the slower learning over a large number of training iterations. So I'm going to talk about the training iterations and the number of epochs and stuff like that in the next lesson. For now, you just understand how the large number of training iteration happens. So this basically increases the likelihood of the network finding a good set of weights across the neural network from input to hidden layer to the output layer, rather than the fast set of weights that minimizes the error called the premature convergence. It's not a good data set, right? Or we are actually enforcing the neural network to define wrong as right and right as wrong, which is actually not a clear-cut AI model, right? So this particular, if you look at the code, the function named update underscore weight, it's a user defined function again that updates the weights for a network given an input row of the data set and the learning rate, and assume that a forward and backward propagation have already been performed, right? So it goes back and forth from the back propagation to the hidden network and the forward propagation to the hidden network again to the input layer. So remember that the input for the output layer is a collection of output from the hidden layer itself. So now that we know how to update the network weights, in the next lesson we will go ahead and train the neural network. That's going to be the interesting game changer aspect altogether, right? So guys, I hope you are enjoying this lesson. Line by line code has been explained to you. Pick up the code from my GitHub. You can bundle together as a one single section and execute your neural network. Of course, there is 1 or 2 more lessons which is pending. I'm going to show you how to train the neural network with the input data sets and walk through step by step the entire neural network. I will see you soon. Goodbye.